My name is Pawan Arora. I'm here with another video on measurement system analysis. People call as MSA. Some people are calling as GageR&R. So all are same. Okay. As I mentioned in my previous video, I'm making MSA because MSA is a lengthy topic. So I'm making almost 3 videos. So first video I've already made on the accuracy. This is my second video on MSA, which talks about attribute gauge R&R, and I will make another video for variable gauge R&R. Okay, so today mostly I will talk about attribute gauge R&R. I'm also showing one very simple game because people mostly ask me, okay, can you make a video which also shows how to do it, how to do attribute gauge R&R. So using this virtual medium, I'm having a very simple game for all of you. I hope you participate in this as well. Okay, so let's talk about attribute gauge R&R. So as you know, MSA is having two parts, the measurement system analysis. So measurement error can be having two parts. One is accuracy, for which you can see my MSA part 1 video on accuracy, and the other part is the precision. So today we will talk more about the precision. So precision has repeatability and reproducibility error, which I already talked in my previous video. But today we will talk in more detail, and then we will have a game of attribute gauge R&R, and finally we will use a mini tab as well to do the attribute gauge R&R. Okay. Now, repeatability and reproducibility, these are the most common terms we use for gauge R&R or for MSA. Reproducibility error mostly comes from operator or operator part interaction. Okay, so you can see in a simple way. So total variations, which is the combination of the variation due to the process and variation due to the gauge R&R. So now gauge R&R variations have two parts, repeatability and reproducibilities. And reproducibility is having two parts, which is called operator and operator part interaction. I will tell you in more detail about operator part interaction when we will take variable gauge R&R. Okay, in attribute gauge R&R we not find these kind of interaction too much. Now, repeatability and reproducibilities, what are those? Repeatability means, suppose I am measuring a characteristic. Let's say I'm measuring the pH, or I'm measuring the height, or I'm measuring the width, or I'm measuring the diameter. So this is a common characteristic of same part of some particular equipment using the same gauge or tool or equipment by the same person, and I'm repeating it maybe twice or thrice. Okay, so that is called repeatabilities, and I'm getting the similar result, means my repeatability is good, I don't have errors. But if my measurements are showing variation, so then I will have repeatability issues. Correct. So that is also called equipment variation, because if I am measuring the same part again and again by the same tool, so it means there are strong chances that, and I'm getting errors, so then there are strong chances that we will have equipment variation. Okay, we will also talk in more detail with the example for attribute gauge R&R in this video. Let's talk about reproducibilities. Reproducibilities is mostly like suppose we have two operators, myself and maybe another person. Okay, we are measuring again same part by different tools, by same tool but different operators. Okay, so then if we are getting variation, so that is called appraiser variation. Okay, AV, and above is called equipment variation. The variation is coming because of equipment, not because of operator, because operators are same. But in this reproducibility case, operators are different. And there is one more term called operator part interaction. I'm just giving you an example. So there are some times when some particular operator are not able to measure, or not able to, or having huge errors or variation at some particular parts. Maybe I have 5 samples, right, and I'm measuring sample 1, another person is also measuring sample 1. So if I am having a differences, okay, that is called reproducibilities. It may be because of operator, or it may be because of operator and part interactions, because parts are also changing 1, 2, 3, 4, 5, and I'm having, let's say for part number 3, huge variation, but other is not having that. So those are called operator part interactions. Okay, I will tell you in more detail in my video number 3, which is on variable gauge R&R. Okay, So as I mentioned, you can have the diameter checking, or you can have the pH checking, gloss checking, height checking, width checking, weight checking, and all these things is you can do this MSA for these things. Okay, and you can check whether your measurement system is working good or not. So let's move on. Type of gauge. So there are two type of gauge. One is called variable gauge and other one is attribute gauge. So today we will talk about attribute gauge. Attribute gauge means where we talk about good or bad. For example, I'm checking let's say the colors. Okay, so I will say color is good or bad. But if we define the colors in terms of, if you already heard about, because many people are from different industries, some industries on the colors. Okay, so if you are from color industry, maybe we call as greener, redder, bluer, and we are getting those numbers. So if we are getting those numbers, then it becomes a variable data. So it depends. If you are checking the variable or the continuous data, then you are doing the study of variable gauge R&R. But if you have attribute data, indirect way, pass, fail, okay, not okay, so these are called attribute gauge R&R. So today in this video we will talk about these kind of data points where you have good, bad, pass, fail, okay, not okay, go, no go, all these conditions. So what is gauge R&R? So it is actually a statistical tool, okay, which measure the variations when we do the repeated measurement. So by involving different operators, so for example, if you are doing the MSA, you will call two or three operators who are well aware about this process, and then there will be one person who will verify that, and he is also very well aware about the process, about the instrument, about the testing procedure. Okay, and then you will start this gauge R&R study, and you also need to understand that at least twice every measurement will be at least twice. So if I am measuring part number A, I am an operator, so I will measure at least two times, maybe at a different time frame. Maybe today I am measuring part number 1 now, and then part number 1 when I will measure next time, maybe after half an hour or 30 minutes, or sorry, 40 minutes, 50 minutes, 1 hour, but I will measure at least two times. Because if you will not measure two times, how you will know the repeatability issues, right? So that's why we have to measure the variation of repeated measurements by different operators. So there are some guidelines. So whenever you are going to plan the MSA in your company or in your site or in your factory or in your offices, okay, so you have to understand these guidelines very importantly. So first is at least twice. So you have to test a sample or test a part at least twice. You can have more than two times, three times, four times, but at least two times it should be. Then sample to be tested may be randomized. What is the meaning of that? For example, firstly I have taken 5 sample, 1, 2, 3, 4, 5, and I am measuring in the same way. Sample number 1 first, sample number 2, sample number 3, and so on. And then when I am measuring second time, because I have to do, or I have to test the sample twice, right? So when I am measuring the sample second time, better you randomize it. Should not give 1, 2, 3, 4, 5, because it will give some kind of hint to the person who is measuring. So better you change the position from 2 to maybe 2, sample number 2 first, then sample number 4, 5, like this. So that is why the randomization is very important while testing the sample. Operator should be well versed, so should know the process. If you don't know the process, maybe we'll have huge variation, and then you have to provide the training to the people. Okay, so better you choose the people who are well versed about the process. If they don't know the process, how to measure it, then definitely they will have the variations. Then your operator variation will be too much instead of your equipment variations or your instrument variation. Then last is the single observer must be appointed. There should be one person who will see whether they are doing it in the same way as they are doing in the normal life, or as they are doing in the day-to-day activity. They should not use in a totally different way. So there should be standard operating procedure, and they should be well versed, and there should be an observer to see whether they are observing or they are doing the testing in a proper way as per the standard operating procedure. So these are the guidelines that has to be followed before planning or before doing the gauge R&R. Okay. Now I have a very simple game, as I said at the start of the video. I have a very simple game. So I would request all of you, please be ready with your notebook and pencil, and you have to answer those questions or those things which are given in the next slides. Okay. Now the game is, you can see there is a ball, right? So this is a good ball. Good ball in the sense it can be of any color. First of all, it can be yellow, white, green, black, and it is a good ball because it is not having any defect. Now defect in the sense there will be some marking. Maybe if I put any white mark on this, or here, or here, or here, or maybe in the center somewhere. So if you have any mark on the ball, then it will be a defect, okay, or a defective ball, or not okay ball. But if you are finding the ball is okay, please say okay. So I will show you around 16 balls, okay. So you can just take your notebook and pen and you just write which ball is looking okay and not okay and send back to me. We will use the data for our attribute GageR&R analysis. Okay. I hope you are ready. Let me repeat. This is a good ball. If you are having any mark on this, then it will become a not okay or defective ball. Okay. And if you are finding no mark, means the ball is okay. I'm going to show you 16 balls now, and you have to tell me your answer. Better the 16 balls is in this form, like one row 4 balls, second row third 4 balls, third row 4 balls, and fourth row 4 balls. So better you give your answer like A1 B1 C1 D1, A2 B2 C2 D2, like this. So if you give me your answer in that way, I think that would be more easy for me to understand and to use that for study. Okay, so let me show you those balls. And yeah, one instruction, maybe you will find some kind of cross or shadow in between, because I have just taken it from Google. So if you are finding any defects, or sorry, any cross or shadow of the balls, that will not consider as a defect ball or defective ball, sorry. Okay, so I'm giving you total 16 seconds, like almost 1 second. Okay, let me be a little bit flexible. So I'm giving you 20 seconds, okay, to see the ball and to write your answer. So your time start now. Okay, time's up. Perfect. Yeah, you please send me your answers. Now let's go to the second trial. So what I do, because I remember there should be minimum 2 trials for doing the GageR&R, right? So there should be 2 trials. Now this will be the second trial for all of you, and as I said earlier, there should be in a randomized basis. So I have changed the balls here and there a little bit. Okay, so again I will give you 20 seconds, 16 balls. Please write your answer in the notebook and send to me. Okay, I hope no question on this. Okay, let's start. And your time start now. Again, 16, sorry, 12 balls, not 16. My mistake. So you can write A1, B1, C1, A2, B2, C2, A2, A3, B3, C3, and A4, B4, C4. I'm so sorry. Okay. 4, 3, 2, 1, and go. Perfect. So meanwhile I'm telling my person to save all the data. He's also using the same ID. So he will save your scores in the Excel file, and then I will show you in few seconds. Okay, what is your answer? Now this exercise, whatever we do, it can be anything. I'm doing it virtual way, so I thought it is a simple and very general way where everybody can participate. Okay, so when we enter into the attribute GageR&R through mini tab, there are 2 ways. One may be with kappa or with k, which is called kappa value, and the other way is without kappa. So you can do the analysis in both the ways, but mostly we use kappa because kappa is also like a constant which will tell us, okay, whether your agreement about the values are poor or not. So if your kappa value is between 80% to 1 or 0.81 to 1 or 100%, I would say it's almost a perfect agreement. Perfect agreement means your answers in the first trial and the second trial are very good, are matching or almost perfect agreement. But if you have less numbers of kappa, let's say 60 to 80%, then it's called substantial agreement, not almost perfect. Then we have moderate, fair, and poor. So indirect way, if you are less than 50% of kappa, so your agreement is not very good. And if you have more than 80% indirect way, so you are almost perfect. So always try to score more than 80% in this. Okay, and I will also show you some z value later on in the Minitab, which you can calculate very simply by kappa divided by the standard error kappa. So you'll get standard error also in the Minitab. What is standard error? If you want to know, please go to my previous video. You can watch that. There is a very good video on standard error, confidence interval and all. Okay, so these values we will use. Now I'm having your results in my Excel sheet. My friend has shared with me. So there are three persons. You can see Abhishek, Raghav, and Swami. So they have given the answer like this. So they have total. You can see there are total A1, B1, C1, A2, B2, C2, A3, B3, C3, A4, D4. A4, B4, C4, D4 like this. They have given the answer like, okay. And I am having your answer, and there is one reference sheet which I know because I am the appraiser in direct way. I am observing you. So I know what is the correct answer. So these are the reference, or indirect way I should say, standards. Okay. So these are the standards against which I am matching your results. And now the problem is you cannot just copy this data and paste it in the Minitab, because Minitab will not work in that way. So Minitab will work in this way. So if you see here, I'm having all your results. So total 96 data points right here. And you have all the operators in the one list. And you have all the data given by the operators for trial number 1, trial number 2. So you can see for Abhishek, we have till here, then we have Raghav, and in the last we have Swami, right? And then we have the reference values, which is nothing but column number this. These are the standard value. So please understand, whenever you are doing attribute GageR&R, please align your data in this way. That's one important thing. Second thing, you have to be very, very careful. If you are writing not okay in this form, so everybody should be in this form. If somebody will write like not okay, so you can see K is a small k here. So now Minitab will confuse, and he will give you not okay separately and this not okay separately numbers. So that is not right. So please be careful if you are writing everything in capital and there is a gap between not and okay. So it should be in that way. Similarly for okay, it should not be small letter, or it should not be in like O is capital but K is small. So my request to you, please review your data before that. Even though you're not reviewing and going and using the Minitab, and you will immediately come to know, yes, this is not right. I have mentioned not okay, maybe one or two not okay in a different way. Okay, so better if you can review your data before going to the Minitab, that is also good. Otherwise Minitab will show you automatically, oh my god, this is something which is not very which is not same or not written same, right? So let me just copy all your data. Let me go to the Minitab for you, and I will paste all your data here. Okay, now let's play with the Minitab and understand what is kappa value, what is the agreement without kappa and with kappa both. So let me just go to the stat, go to quality tools, and go to quality tools, and then you will have create attribute agreement analysis. Please understand, attribute agreement analysis we are checking. Okay, and when we do variable, we have to go to the gauge study, and then we have to check the variable GageR&R. Okay, that I will tell you in the next video. So there are many, you can see cross, nested, and expanded and all. Okay, but for now I am using attribute agreement analysis. Click on this, go to attribute columns. So now there are 4 columns that you have, right? So first is called attribute column. Attribute column is nothing but your data column where you have your attribute okay, not okay and all. Samples, so there is a sample column where we have the balls, right? And then we have appraisers. Appraiser are nothing but your operators. So these are your operators. These are 3 appraisers for us, or operators. And I have a standard column, you can say non-standard. So standard column is nothing but your reference values. Now here you have to go to information. You can also write when you have studied this MSA reported by a product name if you are doing on the product, or any miscellaneous information that you want to give. Then go to options, and now here, see, here is your kappa value. So for now I'm not selecting anything. Okay, and please also display disagreement table as well. I want that. I will show you what exactly is that. And if you want to have any graph is very important, because graph will tell you or give you a hint at the start of the process itself or at the start of your statistical analysis. And then you have the results. So now in the result you have display nothing, then percentage of assessment agreement within and between appraiser, and the last is you want the kappa as well. So for now I am selecting only percentage of assessment agreement. I am not selecting this kappa. Okay, click OK and finally OK. So when you click OK, first of all you will get these kind of graphs. Now by looking at the graph, it gives me some kind of information. So the confidence interval, you can see these are the confidence interval for Abhishek, Raghav and Swami. So by within appraiser means I did the trial number 1. Let's say my name is Abhishek and Abhishek has done trial number 1 and trial number 2. So what is the agreement between, or whether I'm having the within variation or not. Within variation means trial number 1 I'm saying not okay, but in trial number 2 I'm saying okay. So there is a variation. But if I'm saying not okay, or okay both the times, then there is no variation, right? So if there is no variation, then I will say my within appraiser score are very high. So very high in the sense, if you see for all the three, I think Swami is having little bit less score, right? And appraiser versus standard. So we have a reference or the standard column. Against this also, Raghav is very good within and appraiser both. Abhishek is not very good with the standard. Swami is almost the same as within and versus standard. So this is a rough kind of information that you will get, but from there you can see Raghav is doing pretty good. Yeah, let me minimize this and let me go to the session window. So what session window will say? In the session window, it will give you first within appraiser information, then appraiser versus standard, and on the bottom also there are some more things. So let's understand this. So Abhishek has inspected 16 out of 16 match, so their percentage is 100%, or in direct way kappa value is 1. Okay, I will show you the kappa value later on. Raghav is also 16 out of 16, very good. Swami is little bit less, 93, but it's okay. Yeah, because more than 80 is still the perfect agreement. So within appraiser, I think these people are very good. Let's talk about standard. In standard, Abhishek is not very good, right? So your within agreement is very good means your instrument is very good. Instrument is very good. Your measurement system is good. But by looking at the appraiser versus standard, maybe Abhishek is not so good, but still more than 80%. So you can understand, or you can see, okay, maybe some few parts he need little bit of training. Okay, but Raghav is very good. So you can use Raghav to provide the training to Abhishek in direct way. Yeah, and then there is a assessment of disagreement. This is very important. Please understand that. Now, assessment disagreement means appraiser, you can see okay or not okay. Now, what is the meaning of this? Here, the standard is not okay, but your appraiser is telling okay. Let me repeat. Standard is not okay, means the ball is a defective ball, but your appraiser is telling it's a okay ball, it's not defective. So 3 times Abhishek has done this mistake. So mostly Abhishek is not very clear on those balls, because these balls are defective, but he is saying okay. So when he will say okay, it means he will pass this ball and the ball will go to the customer, and finally you will have the issue. So that's why maybe a little bit more training required for Abhishek. Okay. Now mixed means, now what is the meaning of mixed in case of Swami? In case of Swami, mixed means Swami repeatability, Swami within repeatability. Please understand, repeatability in the sense, Swami in the first case he is telling okay, in second trial he is telling not okay. So himself repeatability is not good, but in the top 2 cases repeatability is very good. You can also see within appraiser. So for Abhishek and Raghav, repeatability is very good, but in Swami there is one wrong. So that is why it is called mixed case. So when you have the repeatability issue, obviously you are not within convinced. So definitely you will have a disagreement with the standard. So when you have repeatability, good repeatability, then only your disagreement will start with the standard. So first thing, you are within appraiser. So in case of Abhishek, his repeatability is 100%, but still he is having 3 balls which he says okay in both the trials, but actually it is not okay, right? So this is the meaning of disagreement. Now let's move on. See, you can see also it's written here. So standard is not okay, but the assessment across trial is okay. Across trial means in both the trials. Okay, and mixed means assessment across trials are not identical, means within variation is there. So that is called mixed. Now let's go down and talks about within appraiser. So within appraiser, obviously there are total 16 and all the appraiser assessment agrees with each other. The meaning is with respect to each other there are 13 only matched, so 81%. So this is how you can, and all appraiser versus standard, so this is the data, and here these are the observations that you guys have given. You can see all, right? So these are the standards and these are the areas for D2 and D3 balls. So sometimes people will want to know, okay, which area we have to improve. So I think where you have the counting of 2, 2, and Swami here is the mixed one where he is saying okay, but the ball is not okay, which is C4. So from this study you can see Swami have to cross check why C4 is wrong, and for Abhishek he has to see D2 and D3 ball. Okay, why it was wrong. So from this study you can understand the entire detail, but this is without kappa value, right? Now if you want to see with kappa, let me just delete this entire results first and press Control E. You will be here, and in the results area you please do in addition kappa coefficient, and in the option part also calculate cohesion kappa as approximate. So click OK. Now this already discussed. Now let me increase the size of this window and it will also show us the kappa value here. So now for within appraiser we already discussed about this. Now kappa value. So when you have 16 out of 16, kappa is obviously 1 for Abhishek and Raghav, but for Swami the kappa value is less. It is because you have one unmatched out of 16, you have 15 match, so your kappa value is 0.871 or 0.87045. You can see. Now from where this value is coming I will show you in my different slide. Okay, but for now you just remember for Swami the kappa value is 0.870 for within. I will show you how to calculate it. Okay, then standard error of kappa, you can go and watch my different videos. You will come to know what is the meaning of standard error, from where it comes. Z value, I already told you, if you divide this kappa value with the standard error or standard kappa. So for example 1 divided by 0.25 you will get 4, right? So from this Z table you can get your p values, and now p values is 0. Okay, so you have to reject the null hypothesis. Now when you reject the null hypothesis means you will say, so null hypothesis means there is no agreement or no matching, and hypothesized value means there is an agreement. So now here in this case your p value is less than 0.05 means you will say there is a good agreement. Good agreement means all these people within or repeatability is very good. There is not much error, right? When you go down you can see the kappa value for each and everything. Now the kappa value for appraiser versus standard is also there, and from this also you can get your p values, right? You can see your p values, you can see your kappa values. So for kappa values I think Abhishek versus standard is not very good. Okay, so it is somewhere close to 60%, but I will not say, because you know from 60 to 80% there is still substantial agreement. So I think for these cases Abhishek need little bit of training, and you can use Raghav for providing the training to Abhishek, because Raghav is very good for within as well as versus standard. Okay, and similarly you will find the within details for your kappa values, right? So this is the kappa value of within, and p value says yes there is a good agreement. Out of 16, 13 are matching, and 13 is majorly because of, I would say, 1 for Swami and 2 for Abhishek, right? So from this entire detail you can get your attribute GageR&R study, and you will come to know, okay, which person is doing what, whether your measurement system. So in this case our measurement system was our eyes, because we were just visually checking. So our eyes are good or not? So I would say eyes are good, because your within variations or within scores are very good, right? But there are some cases where your Abhishek is not doing so good when compared to the standard. Now as I mentioned, in this case your kappa value is 0.87045 or 0.871 in direct way. So how to calculate this kappa? So there is a formula. Let me show you that formula now. So formula is this. This is called PRA. PRA is nothing but the probability of agreement. Believe me, you will not find these kind of details in anywhere in any of the videos. but I am giving you a very simple example, the same example which I shown you in the mini tab, and later on you can calculate the kappa value for anything, any agreement or disagreement, right? So the formula is very simple. Probability of agreement minus probability of error divided by 1 minus probability of error. If you guys have learned probability in your ninth or 10th classes, you can understand mostly we use these kind of formula to check how much is my probability of agreement across within everything, indirect way or with respect to the error. So this is the formula. Okay, now how to check it? Let's take the same example of balls. If you see this small window for Swami, okay, and you remember for Swami the answer was 0.87045, and we will see how it is calculated. You can see the answer here. Now for Swami, for trial number 1, he said not okay to the 6 balls, and 1 ball he said not okay in the trial number 1. Okay, for trial number 1 again, okay balls he said okay to 0. For 9 balls he said okay for okay for the trial 1. Okay, now this is for the trial 2, not okay. Now, oh sorry, okay, I think it's my mistake. Let me explain you in other way. Please forget this. Sorry. So what's the meaning of 6 means? In the trial number 1 we said not okay. In the trial number 2 also we said not okay to the 6 balls. Let me repeat. Trial number 1 I said not okay. Trial number 2 also I said not okay to 6 balls. Trial number 1 I said okay. Trial number 2 I said not okay to 0 balls. Okay. Now trial number 2 I said okay. Trial number 1 I said not okay to 1 ball. Trial number 1 I said okay, but trial number 2 I also said okay to 9 balls. So if you add all these balls, you will come to know there are total 16 balls, right? So out of 16 balls, I said not okay both the times for 6 balls. I said not okay in the first trial, okay in the second trial to first ball, okay and not okay in different trials, like trial number 1 okay, trial number 2 not okay to 0 ball, and then 9 balls I said trial number 1 okay as well as trial number 2 okay. So this is what the simple table I made to calculate this kappa value. Now let's understand and go deep dive how to calculate. So your probability of agreement TRA is equals to, out of this, how many were the agreement in the sense when you said not okay in the first trial, second trial also not okay 6 times, and here you have okay in the first trial, okay in the second trial 9 balls. So there are total 15 balls you said, or you are having agreement in both the trials, correct? Out of 16 balls, so 15 divided by 16 is this number. Okay, and this number is also same as you can get in the mini tab here. You can see. So 15 divided by 16. This is nothing but your agreement part, right? Assessment agreement you can see on the top. Now, let's talk about errors or non-agreement stuff. So trial 1 is not okay within. Trial number 1 is not okay within is 7, right? You can see here 6 plus 1, 7. And trial number okay within, okay, is 9. 0 plus 9 is 9, right? So probability of not okay will be 7, this 7 divided by 16, and probability of okay will be 9 divided by 16. Similarly, for trial number 2, not okay is 6, 6 plus 0, and okay is 9 plus 1, 10, right? You can get the probability 6 divided by 16 and 10 divided by 16. So now you have the probability of not okay as well as probability of okay, right? So now the probability of not okay in both the trials, in trial 1 and trial 2, is nothing but this multiplied by this. You will get 0.164, and the probability of okay in both the trials is this, which is nothing but multiply of these two. So when you multiply, you will get 0.3515. Now the total probability or the probability of errors. What is the meaning of error? Please understand. When I'm saying okay in the first trial but not okay in the second trial, so this is called error, right? So I have checked the probability of not okay, I have checked the probability of okay, and then the relative probability will be sum of these two, right? So sum of these two is 0.5155. So now the K value, the K formula is the probability of agreement, which is this 0.9375. Probability of, sorry, the probability of agreement is the probability of error, sorry, is 0.5155 divided by 1 minus probability of error, which is 0.5155. If you calculate, you will get this 0.871, or in direct way 0.8705, which you can see in the mini tab is here. Okay, right. So I hope you understood how to calculate the kappa value for this, and I hope you also understand how to do the attribute agreement analysis or attribute GageR&R through mini tab, and how you can also analyze whether it is agreement or not agreement, to which operator you need to train if there is any operator issue, or also you can check if there are any eyes issue. Sometimes your within score is not very good. In this case, the within score was good, but some cases maybe your within score is not very good. So overall, I would say Abhishek, Swami, and our Raghav. So all of you are very good with respect to the eyes, and overall kappa value is also very good within. Some issues are there with Abhishek that we need to cross check what exactly it is, whether he need any training or something. So those kind of actions we can take. Okay, I hope you like this video. As I said,